Alright, so this is an attempt at explaining how the Switch GUI works and the boot process specifically. So it's a bit complex because there are several frameworks going on here at once, but hopefully this shouldn't be too hard. So this is the main repository for the GUI. It was mainly developed by Ale, who worked on Switch in 2015 or 2016, something like that. She's from Vietnam. And there are several files here. The file directory structure is a bit complex, but hopefully we can make sense of it. So this is the main directory where we have the README, which is this thing you see right here, the license, the git ignore, and then 3 folders. The main application is in the source folder, which I'm going to be talking about right now. The examples folder is the example data to input to the actual application to see the visualization output, and the assets are related assets for the GitHub pages, I believe, which is this page right here. So within the source folder, we have a lot of stuff, and it's not so straightforward because we combine several frameworks into one. So the main view layer is built on React.js by Facebook, but the main structure for the whole application is built on Meteor, and on top of that it's all wrapped in an Electron application to make that desktop application wrapper and make it run in several different platforms. So Electron is this project which basically wraps the applications to be able to run them in a desktop environment as opposed to a web environment. So yeah. So if, like me, you're unfamiliar with Meteor, the first thing you need to do is go read this thing, which is part of the Meteor documentation called Application Structure, which describes most of what is going on in the Switch GUI. Basically, it's all ES6 based, so imports and exports work exactly like you would expect them to. The file structure is particularly opinionated. Meteor is sort of a framework where you have both the client and the server in the same application. It's transparent to the developer, and they both run on JavaScript, and basically everything runs on JavaScript. So yeah, you have 3 main folders, which are imports, client, and server in your root directory. Server and client and server is both where the client application code will go and the server application code will go. And the import is where everything else that you want to import will go. Now Meteor encourages people to put all of the logic of the application into the imports folder and put absolutely nothing into the main.js and the server and client main.js servers for some reason. I find that's a terrible pattern, but apparently Meteor developers dig that. But yeah, these are basically empty files which just import whatever it is that's in the imports folders, and you will see that that is the case for the Switch GUI. So if you have the client main.js, it basically just imports, and the server main.js also just imports. I have several other files here, so I'm going to expand right now. So you can see that I followed the exact same pattern here. We have a server folder with the main.js, a client folder with the main.js, and an imports folder with everything else. Even within these imports folders, you have the API, startup, and UI folder, which is what Meteor apparently recommends. Let's see what else. So we have some public for images, style sheets, and other such data. And then we have a few of these dot folders, which I'll explain in a bit, and the client folder, which is the same pattern. Yeah. Okay. So there's a lot of hidden things in the directory structure. So if you just ls here, not here, but in the source folder, you'll get a lot of stuff that that's not shown because it starts with a dot. So you have to do ls a, pass the a flag for all, and you'll see the whole thing. If you're using a text editor like Sublime Text, you'll see the actual files here. Some of these things are pretty standard, which is the Babel configuration, a file for editor config, which is a main global standardization, attempt at standardizing editor configurations across different editors. So the type of end of line, the indent style, what size is the indent, the charset, and these other options. You can add whatever you want here, but these is generally good practice to standardize this type of things across all the developers that are contributing to the application. Then you have ESLint configurations, which is the linter configuration that you ignore files. And that's it for the yarn.lock, which is the dependencies manager. Instead of npm, we're using yarn because it's a lot faster. And this is just the lock file, which details all of the sub-dependencies for each dependency. This to-dos thing is my thing, so just ignore that for now. Then there are several JSON files, which are mainly configuration. You'll see them in the code once we go through right now, but these are mainly configuration. The packager.json I'm not going to go over because that's for packaging when you want to distribute the application. That's not something I want to do right now. The main file, I guess, is the package.json, which is common to all Node.js applications. It specifies the name of the application, a description, what version it's currently at, the author, this is Alice, male, some script, the list of dependencies, which is pretty huge for this project, and the developer dependencies. There are some main things that are important to note about this package.json, which can more or less guide you through the code. So the first thing is that we're using GraphQL for database. This is not really relevant right now, but it's there. Using React for the view layer. Redux is also being used for data handling. Lots of Babel plugins. Electron for packaging. ESLint for the linter. And apparently we're using Mocha as a testing framework. And that's basically all that's interesting from this. What is interesting about this is that there are some configurations here that are specific to the Electron files. So if you go to Electron, to the Electron repository, which is here. So let's go to the quick start, and this is an example of an application that runs on Electron. If you try to get started from this particular one, the structure is very, very different from what we have in the actual GUI, so I don't recommend it. The important thing is that there's a main.js file. This is the app's main process. And the package.json is also relevant here because it points to the app's main file. So in this package.json, you should have a main key that points to the name of the main file as specified here. So this is what this main directory is, specifying here in the some Electron versions and Mongo version. So it's telling you that the main file for the Electron application is this index.js. Now, the loading, as you will see, will happen in different stages. So the first thing is that the first and foremost, this is an Electron application, so the first thing that will run is Electron, and Electron is in charge of running the actual Meteor app. So you need to specify. So this is the thing that gets run when you do yarn run dev. Now, because the main file is yarn.rev, so if you go into the source file, there's another readme here that will specify how to install and run the application. What you need to do once you've installed the different packages is yarn run dev, and run dev will basically run this script, which is in the package.json. Notably, the first thing that's run is not Electron. So if you go to the Electron app, the main script to run is just the Electron binary package, and which runs in the same directory of the application. That's not what's happening here, and there's an important reason for that. There's a complex booting process that goes on into the script run. So the first thing that you need to do is run, go and see what script run is, and I'll attempt to make a line-by-line explanation of what's going on in this part. This is the main thing, like the main entry point for the whole Electron application. We're not sure that we're keeping the Electron application right now, but as it is, this is the version that I have not modified yet. So it is an Electron application, and I just want to attempt at explaining it as is, how it is, how it's actually like currently implemented. So as to the run.js, there is this. Oh, and an important thing to mention is that Ale apparently, she didn't tell me this, but after lots of reading the code, spending several hours of this, it was apparent that this was not entirely her code. So this is this looks like a boilerplate to combine Electron and Meteor, which is something that people should have never done. But I didn't find it after a while. The actual repository is something that's not even popular or maintained very regularly. It's called Bootstrap Electron Meteor. This was actually, the last update for this was in almost 2 years ago, more than 2 years ago, by this guy called Jorn Brethen, who I have no idea who that is. But basically he did this like boilerplate for combining Electron and Meteor. It's pretty old, so this probably is a bad idea, and it's got some really, really bad code smells. But again, this is just the current standing of the code. So she basically cloned this, I assume, and started working on top of that. There's a lot of changes here, so she fixed some of the code smells and added some of her own things. The main thing is that, for example, you'll see that these are the actual folders, but she put them into a .scripts, .meteor, and .assets folder for some reason, and that we'll see. She deleted some of the Sabvayer stuff, JS hint RC, because we're not using those things, but the main code is just the same thing, right? So within the scripts you have this run.js, which does not differ greatly between this original version and this version right here. Now this thing, as you will see in the README, is in turn based off something called Electrometeor, which is by this guy, Sir Charles Watson, and it's not even maintained as much. The reason for that is that Meteor was popular in 2015 and then it suddenly dropped out of popularity, and the main reason for that is that it's extremely slow. But yeah, so this is not even supported anymore. So but yeah, it's there. The differences between this one and this one are quite substantial, but it's there just so that you know and have that as a reference. The differences between this version and Ali's version are not terribly complicated. So let's go through it line by line. So the first thing that we do is import shell.js, which is a node package to run commands from as if you were in a Linux in a Bash shell. It's importing the whole thing into the global namespace, which is a terrible pattern, but this is what the guy does. So I assume that it's just more comfortable. As a reference, this probably not be in the code because it's terrible, but it's there right now. Colors is just a way to color output in the terminal. Then it imports child process and path. Child process is an npm package that allows you to fork different threads of the main process, and spawn is the method that does the actual fork. Or this will create a new process, and fork will make a new thread. So just like you would expect that in Linux threads. Path is just a way to standardize paths across different environments, so distributions of operating systems. We're first specifying that the node environment is the development environment, because stuff works very differently if you're in development or in production, for election applications at least. You have the base path, which is just this, not this folder, but the one above it, so this source folder. This is where everything lives, basically. Getting the platform, getting the architecture, a check to see if we're in Windows, because everything has to be specialized for Windows, and a flag whether Meteor has been started or not. So at this point it hasn't been started, so it's false. And then the cd base is to run the commands. Whatever shell commands are going to run are going to be run from this source app as opposed to this scripts folder. So the command for Meteor is different if you're on Windows, because that's a bat file as opposed to an executable file or a shell script. Once you have the actual command that you want to use, you spawn the process to that for that one. Meteor.bat, if you've installed the requirement for Meteor, will be in the user's path, so you can run this. So you spawn a different process for this. Once you've done that, then you configure the output for these for Meteor to be run into the same shell that this node run.js is being run in, which is just your main shell where you ran the application. So you set the encoding for the Meteor standard out. On data is just an event that this child process provides to hook onto the output when it receives output. So when you receive an output for the Meteor standard output, just console log it to our current console. If you find a line that reads Meteor app started, and this is a terrible way to do it with index alphabet because it's very slow, but if you find that line, then check if the Meteor started has been started before. Otherwise, start electron and set the Meteor started flag to true. Do the same thing for the standard error because we want to see the standard error. And finally, bind an event when the Meteor standard out has been closed. You can kill the electron, which was started here. And then she does the same thing for electron. The start electron thing runs after the Meteor has been started. So for starting electron, you print something out. You get the election path. So this is the actual absolute path where the electron binary file is, which is in the node modules folder. And then you execute, again this is from the shell.js, you execute the electron path, and you have to pass where is the application, so the root folder for the application, and then this is just the base folder for the source. And do this asynchronously, so return immediately, set the encoding for the standard out, do the same thing for the data, and when the standard out has been closed, kill a meteor. And the kill meteor basically just task kills if you're on Windows, or sends a SIGINT signal on Unix systems for both Meteor and Electron. So the main thing that's going on here is that Meteor is started first. So once Meteor has been started and the complete app has been started, then you can start the wrapper for Electron. The reason for that is that the client and the server need to be run first before you run the actual shell, because the shell is only the view layer for that, but the server and the database server, which is what's consuming most of the time in this operation, has to be run first. This is all there is for run.js, and then you once you've started the Meteor app, so two things have been started here, the Meteor application and the Electron application. The Meteor will by default load the server and the client, these main.js files, and there's a nice write-up on the Meteor documentation as to what gets loaded and in what order. So this is the file load order. But basically it will load the main.js files, and that is the main entry point for both the client and the server for the Meteor application. So anything logic-wise for the Meteor application will go into these files. Once this has been loaded, the Electron app will run, and the Electron app does a few more interesting things in this .index.js file, which is in the root directory, which, if you remember, is the main file for the package.json. So let's take a look at what's in here. Again, this comes from the repository that was cloned by this guy. So this one, Bootstrap Electron Meteor, Bootstrap, and it's this index.js. I have this file open here just to compare these things. These are not terribly different, but it's interesting. For one thing, I did change the whole syntax from ES 2015 to, ES5 to ES 2015 or ES6. So gone are the vars and gone are the function declarations that start with function. So this will import several things here. Electron, which is needed to run the browser window. So this one will look a lot more like the actual main.js file that's in Electron. This one is a lot simpler because it doesn't need to do as much. So it only requires Electron, gets the app, gets the browser window, requires path and URL, keeps a reference to the main window, has this create window function, which is the actual thing that creates the window, and sets some event handlers, so on ready, on window on closed, and on activate. And this function create windows is really simple as well. So main window, it instantiates a new browser window with width and height. It loads a URL, which is just the index.html or a file or an actual URL for a server endpoint. And on close, it just sets the main window variable to null. This one is a bit more complex, but basically it requires Electron. Again, we need to start some child processes. We need the package.json because we are obtaining some configuration from there. And then path, net, this is OS, operating system, FS, file system, because we need some files from the file system. The only thing that we're using from the package.json is the name, so we don't even need this variable, I think. Yeah, so renaming the process.env for some reason. These are the type of code smells that I was talking about earlier. We're redefining, or rather polluting, the the symbol table or the environment with new variables that are not really needed. There was this one as well here, dir name, which points to the underscore dir name Node.js variable, and this was just too much because it's literally only used twice. So I just deleted that, but this happens several times in the code. So here is basically a lot of variable setting. So where the server will run or is running, where the MongoDB database, which is what is being used as a database, is going to run, and what's the name of the database that's actually running here. These are some settings for the actual browser window that will run the application. Then we get some paths, so where is the resource directory, the Meteor server path, and the MongoDB path, so the actual files in the file system that contain all of these folders. These are only used for production servers, like this for the production version, so they're not really relevant to us right now. We do need to know some information about the platform. So if you're Darwin, this is Mac OS. So this is where the application path will be. So where the destination files will be run. So on Mac OS, this is home, library, application supports, and then a folder with an app name. On Windows, it's app data local, and the application name. And on Linux, it's just a .config folder inside of the home path. The data path is just the application path plus /data. Then you console these things. These are not too different, so you set up some information about the browser window, get the same information for paths, and then you define some helper functions. So basically these are exactly the same. Start note. So these are the helper functions, which we'll go into a bit more detail right now. Then you do the exact same things that the electron main.js file is doing. So you define a create window function. Oh, you get a reference to the main window, and the global namespace. This is not actually necessary because this is enough, but it's there. You define your create window function, and you set the handlers. So when the application is ready, create the window. When the application is activated, if the main window is null, then just create the window. And here it says what this is. So on OSX, it's common to recreate a window in the app when the dock icon is clicked and there are no other windows open. So yeah, basically this code is only for Mac OS. And this activate with no open windows, and there's a comment specifying what this handler is for. So let's look at these helper functions first. So create your sync is from the file system in Node.js. Basically, if the files, if the dir does not exist, then just create it. It's not really necessary because make dir already checks whether there's a directory with that name, but you know, it's there. The same thing for read file sync, and the sync here just indicates that this is a synchronous process. So if the file exists, it reads it and returns the actual string content, which is this UTF-8 parameter. That's what it does. And we'll see what these things do. Okay, so the create window, it first checks if this is a test build. So if this Electron application was run with something called test build as a second argument, then it will do some things differently. So if this is not a test build, then it will actually instantiate a new splash screen. It'll focus it, and it will load a particular file called .splash.html, which is in the root source folder, which is this folder, which is this file right here. And this is just the splash. It's just the thing that first appears when the application is being loaded. It's not properly configured because this thing happens so fast that you can't actually see it, even when the actual application takes a long time to load. But I guess that was the idea. So that's only for production environments. Sorry, for development environments, yeah. Once it's done, that it will run the start function and it'll pass this huge callback. The same thing is being done here, except that this wasn't actually put into its own function. It's just passed as the callback of onReady, and it doesn't show a splash screen. We'll go into what this callback does in a second, but first I want to take a look at the start function. Basically what this will do is run some things first, and when everything is loaded in start, it will run this callback. So we first need to go look at what the start function does. And as you can see, it receives the callback here. So first thing to note is that if the environment is a development environment, it actually won't do anything. It'll just run the callback with the default URL of localhost 3000. And the reason that it's using localhost 3000 is that the Meteor server in development mode will run in the 3000 port. So it's basically telling it the app is running in the 3000 port, because this will be true for the development environment. And it returns immediately. The start function here does exactly the same thing. Now, if it's not in the development environment, it'll do several things. So it will write the standard out. It's starting the production server. So if this is a production version, it will create the app path and the data path where the files will live, and that it will run in quick succession these free port stuff. This is what's meant when people say callback hell. So this is a bad pattern as well. But yeah, you can see that you have 1, 2, 3, 4 callbacks. 5 if you. So this is callback hell. But anyway, so let's take a look at this free port function. What this free port function does is determines an unoccupied port. Now this is slightly misleading because that's not the only thing it does. It determines an unoccupied port, and it starts a server on that port. So because you can't assume in a production environment that port 3000 will be available, it'll just ask the operating system for an open port and run the application on that port. So that's what this net package is doing. It'll create the server, and it'll define the port. And when the server is closed, so what it does is it's a bit weird. It creates a server, and this net.create server will automatically assign a port number that's free on the operating system. Then it just starts that server. Once that server is listening, you get the port number, and then you terminate the server. Once the server is terminated, then the callback is run. And this effectively gives you a free port. It's an ugly way to do it, but again, it's there. So once the callback is being run for the first time, the first thing that will be created is where the web port will run. So the first thing that you need is a port for the server, and then you need a port for the MongoDB. Now, Meteor.js comes with its own distribution of Mongo, even if you already have one installed, so you have no choice over this. So once it's got an available port for the web server, it'll get an available port for the database server, which is the Mongo. And once that happens, if there was an error, it'll throw the error. It'll print out the ports, and it will delete the log files if there were any. So this is a if this is not the first run of the application, some log files will have been created in the data path, at least for Unix environments. So it'll delete those. You're not even using WireTiger here, so I'm not sure why this is. This line is here, but again, it's there. And once all of that has happened, it can actually start the database server. So start Mongo is this function that comes here. It hasn't yet actually run the initial callback function, which is this huge function here. So it's first will start the Mongo server, and it'll pass the callback to this Mongo thing. So you set a false flag because Mongo has not been started. You define the actual parameters or the arguments that you would pass if you were running Mongo from the terminal. So storage engine is nmap v1, and this is what I mean by you're not even running WireTiger, so it wouldn't be there. Nmap v1 is just the storage engine that Mongo will be running in. You bind it to the local IP so that it's not exposed to the rest of the world, on your LAN anyway. The database path, so where the data file is going to live, what port is Mongo going to be running in, a small file flag, and a journal to keep transactions in a journal. So if the platform is not Windows, then also add a Unix socket prefix, because sockets in Unix are actual files. So yeah, you need to add where that will be stored. Once you set the configuration for the Mongo arguments, you can spawn the actual process. So in the Mongo path, run it with the Mongo args, and set the environment variable purpose to app name. I'm not sure what this is used for, but it's there. Then you do the same thing with the standard output and standard errors. We want to see them in our actual shell, so redirect them to us. In the standard output, we know that there's been an error in Mongo if there's something called assertion. So if there's an assertion, then just throw it. We're apparently identifying that Mongo is running if there's a line with waiting for connections and port. Again, indexof is a bad way to do it, but it's there. So if Mongo is actually running, then set the started flag to true, print that Mongo has been started, and then start node. So the callback is still not passed here. Is still not called here. It is passed to the start node function, which will in turn start the node server. And we also receive a Mongo child, which is this spawn process. So it's the reference to the actual process that's being run. Finally, start node does exactly the same thing. So it'll look for something called boot.js, which Electron will put out into the actual compressed archive. You'll have to specify a root URL, which is the domain and the web port that was assigned. The domain again is just localhost. Set the open flag to false. set the node environment variables, so the root URL for the application, the port of the application, where the database is, where Mongo is, some settings for Meteor, which is what this settings.json file contains, so that's why we need this file system thing. So if you remember, there was this empty settings.json, so if you have settings for Meteor, they will go here in this JSON file. This is obviously running in production mode because we've already checked that we're in production, or rather that we're not in development mode. And this is a flag for Electron as well. So once you have that, you can create a thread with this fork method with this argument. I'm not entirely sure what this is for. And the environment. And this flag silent true to be able to listen to standard out and standard error. Once you have that, you store that into a reference of the actual process that's running. You redirect the standard output and standard error. Once you have this line, Meteor app started, that means Meteor is running. And you set the flag to open to true, and within 100 milliseconds you can actually call this final callback that you passed to the start function. This is the exact definition of callback hell, so really this should be seriously restructured. So this is our actual logic. This is pretty independent of whatever your application is doing, because you always need to start Mongo and always need to start Meteor if your application is running on Meteor. But finally, if once Mongo is loaded and Meteor is loaded, if you're running a test build, then that's all you need to do. Otherwise, print that the app is occupying this thing. We have this cleanup function, which is for cleaning up after ourselves. We'll see that in a second. We set the window options for the actual Electron window, so width, height, min width, resizable, and frame, which were defined up here. It's not the cleanest way to do it because again we're polluting the namespace, but you know, it's there. Title bar style hidden. This is a macOS only option that will hide the title bar and just show the small closing, minimizing, and maximizing dots in the left side. Show equals false. We don't want to show the window yet. And these I'm not entirely sure what they're for. But this preload file is this preload thing. That's right here in the root of the application. So apparently Meteor overwrites the required method, which is a stupid thing to do, but we have to do a copy of that, which is what the preload function does, or the preload file. Once you have those set down, you can actually create an instance of a browser window, hide the menu bar, focus the main window, close the splash screen, which is again something that's not currently working, load the URL, which is the main URL, which is going to be either what's running in production or this default. Where is that thing? Default localhost 3000 URL, which is where the application, the Meteor application, is running. Then you assign the global variable main window to this actual instance of main window. If you don't do this, if you don't maintain this, again, the global namespace is not necessary. This main window variable is enough because it's outside of this create window function. If you don't do this, then the window will be closed automatically when the JavaScript object is garbage collected, and you don't want that. So, and then you set some event handlers. So when the thing is ready to show, then show it. If you're in a development mode, then show the dev tools as well. If there's an uncaught exception on this process, then just clean up. If the main window is closed, then remove the reference to this main window object so that it can be garbage collected. Once this event did finish loading runs, then for some reason just print the event. And these are all, by the way, Electron events, so you can look them up in the documentation. So when the application will quit, clean up, and when all the windows are closed, clean up as well. And now is the right time to see what this cleanup function does. It prints that it's going to clean up. If there is a reference to the no-child process, then kill the no-child process. Again, this is not being correctly killed because you have to account for Windows environments. If there is also a Mongo process running, then kill that Mongo process as well. And finally kill the Electron application. And that's basically all that this file does. Once this file is run, then you will get the actual browser window that will show the application running. It's a huge pain in the ass because there's different entry points for this application, depending on whether Mongo is starting, Meteor is starting, or Electron is starting. But yeah. Again, we're not sure if we're going to keep the Electron wrapper, but or the Meteor wrapper because they're incredibly slow. The important thing is that this means that the Electron app does not have to be run. So if you're running in a server that has no graphical interface, so if you're running Ubuntu server or something like that, then you don't necessarily need to run the Electron app. You can just run the Meteor app, and that will run the server and the client, which you can access in a browser. As proof of concept, I have this. Once the actual Electron application is running, the server is still running, so you can still access that through the browser, but you can bypass the Electron thing altogether by instead of running so instead of running yarn run dev that will run the Electron app, you can just run Meteor run, which is how you would run a normal Meteor application, and this will actually load up just the Meteor files. It's kind of ugly the way it prints it here, but eventually it will. It'll take a while, even if it's not the first time you run it, because Mongo is really heavy and the Meteor app takes really long time to load. But again, we're not sure that we're keeping that precisely for those reasons. But yeah, that's basically the whole boot up process for Switch GUI.